This whole video is about me learning about this bacterium and extracting its antibiotic. If you just want to see me extract the antibiotic, I'd recommend skipping ahead. Otherwise, enjoy. When I began this project, I had never heard of Streptomyces until I came across this post on Discord where someone was confused on why the Streptomyces, which normally appear stringy under the microscope, were instead showing up as circles. After a quick search, I learned that Streptomyces are a type of bacteria that usually form thread-like structures called pseudomycelium. These structures mimic the branching networks called mycelium, which present in mold form in fungi. But this raises the question, why aren't we seeing those thread-like structures? Why were we seeing circles instead? Well, Streptomyces can form spores, but unlike fungal spores, these are bacterial spores, which are often referred to as endospores, which, unlike fungi, these form specifically inside the cell. However, I later learned that Streptomyces are somewhat an exception to this rule, but we'll get to that later. Anyway, the person on Discord had already tried to determine whether these circular structures were bacterial endospores by performing a malachite green stain. A method I'll explain and do later, but anyway, the stain came back negative. There was no green anything, no spores. I was left very confused. I didn't understand why, as nothing else could explain what we were seeing if it truly was Streptomyces. But now I was thoroughly interested and wanted to see this for myself, so I pulled up Carolina Biological and bought myself 2 vials of Streptomyces griseus. In an attempt to understand what was going on with the stains in microscope photos, I put together a 10-day project called the Streptomyces Spore Project. But this project may or may not have ended in failure, and unfortunately this early part of the project was not filmed, so I reenacted it for this video. Anyway, in order to start the project, I would first need to spread the Streptomyces bacteria I bought over a gelatin-like substance called Streptomyces agar. To make the agar, I weighed out 6 grams of agar-agar to form the gel. 2 grams of yeast extract as minimal nutrients that favor most bacterial growth. 2 grams of dextrose to favor Streptomyces growth as they prefer dextrose. And then interestingly, I would add malt extract, which mustard growing enthusiasts sell in the masses on various shopping sites and mostly back form as malt extract agar, which is malt extract and agar-agar mixed together. I had some on hand from when I had grown fungi in the past, but I painfully found out my bag wasn't shut properly and had become a rock. In spite of the mushroom growers, I scoured Amazon and tried to find it in bottle form as just malt extract without any agar added, as it just made the process confusing. After painfully looking through crude listings of raw malt and more bags of agar mixes, I found an extremely expensive bottle of malt extract that was several times purer than what I had been using before. I postponed the project until it arrived, and I weighed out 5 grams of malt extract, which reminds me of fungi a lot more than bacteria. The final ingredient was something to keep the pH balanced, which was 1 grams of calcium carbonate. After weighing everything out, I took a borosilicate media bottle, added 500 ml of distilled water, and poured everything but the agar-agar in calcium carbonate. I then tightened the cap and shook the bottle until everything was dissolved, and then added it to the hot plate with a stir bar and turned on the stirring. Once the solution turned clear, I added the final ingredient, calcium carbonate. Wait, no. I didn't. Oh. I now had a liquid solution of Streptomyces agar, but it was contaminated with spores and microorganisms from the environment, and I needed to sterilize it. One method to do so is called autoclaving, which pressurizes steam to 15 psi to increase the boiling temperature of water to 121 degrees Celsius. After 15 minutes, this is enough to kill most microorganisms. Ah, dude, I'm drinking. I'm already gonna finish my 3rd Sunkist. After 15 minutes, this is enough to kill most microorganisms, as well as destroying the spores some of them use to grow back. To do this, I added water to the bottom of my induction-capable pressure cooker, put in the strainer in the agar bottle with the cap loosened to prevent it from becoming a pipe bomb, and I added a strip of autoclave tape on top. Oh wait, I didn't. Oh no. Yeah, I forgot to do this. I had to end the autoclave early, and yeah, you remember that calcium carbonate I weighed out earlier? I never added it. So yeah, I had to add the calcium carbonate to keep so the pH stays adjusted, and I had to add a piece of autoclave tape on top. I then, for the second time, sealed the lid and put on the 15 psi pressure regulator. Then I turned on the induction cooker. Once the autoclave reached 15 psi, I started a timer for 15 minutes. Once the 15 minutes were up, I lightly lifted the pressure regulator to release the steam faster. I don't recommend doing this as it can cause many things that you don't want. Once the PSI was 0 and the pressure indicator dropped, I then removed the lid with heat-resistant gloves. I then tightened the bottle of molten agar and removed it from the autoclave. I forgot to include this in the script, but when you remove your bottle from the autoclave, it is really hot and agar solidifies at around 40 C. If you were to pour plates right away, you'd have to wear gloves and it would cause steam to condensate on the lid, which would ruin your plates. So I put them in this chamber which is heated to 50 C, which is the perfect temperature to pour agar plates at if you're not inoculating them before pouring. Notice how the autoclave tape is black. This means that the pressure cooker successfully reached 121 degrees Celsius, which means my bottle is probably sterile now. Now, to ensure it stays that way when pouring it, I have something called a laminar flow hood. This is basically a fan behind a very nice filter. This filter is fine enough to trap any microbes and spores from the air inside of it. This allows the air coming out in front of it to be sterile and an area wide enough for me to pour in. I turned it sideways to accommodate my bottle and laid out stacks of petri dishes. I then turned on the hood and opened my bottle in front of it. And I used a tiny blowtorch to sterilize the pour ring and lower area, swirling the bottle gently to suspend the calcium carbonate stuck to the bottom. I then carefully poured each plate around halfway in the stack and then swirled them all at once. Once they were all done, I let them cool and put them in the fridge for later. Now I could finally begin the project as everything was prepared. I set my incubators to 30 degrees Celsius, which is the incubation temp of Streptomyces, and pre-warmed my agar plates to incubation temperature. I now needed to spread the concentrated Streptomyces bacteria I bought over all of the agar plates. Because of their solid nature, the bacteria would stay in place when spread over the agar, and if spread thin enough, one bacteria could multiply itself far away from the rest, forming a visible sphere of just itself called an isolated colony. But due to the bacteria's concentrated nature, I would have to sterilize the spreading utensil after every spread and dig into where I've already spread just a little to start the streak again, to effectively lower the concentration of bacteria to get me separated colonies. This is called streaking for isolation, but unfortunately either my loop sucks or I do, because I messed up a lot. So many swear words were released during it. I had to be so careful during it that it took me over an hour just to streak 30 of them, and I had to start pulling spare plates out of the fridge. Once they were done, it was time for incubation and the project was finally started. Now each day of the project, I planned for several things to be done to each plate. The first thing being a gram stain. This would determine whether the bacteria I grew was gram-positive or gram-negative, which is basically a type of cell membrane bacterial cells have. A gram stain traps a purple dye called crystal violet inside of gram-positive bacteria, but fails to do so to gram-negative bacteria. This allows us to see the bacteria's shape and what type of cell membrane they have, which tells us a lot about whether or not we are looking at the right bacteria. Now, if we want to know if they have endospores, we do another stain, called a malachite green stain. This stains the spores green and enlarges them, which allows us to see them under the microscope. Anyway, this is where I ran into my first issue. After reading about the incubation time of Streptomyces online, I found it to be around 72 hours to see isolated colonies. Well, I painfully found out this isn't true and I probably should have researched better. After less than 24 hours, the first plate I labeled to take out had growth, and I didn't believe it because I hadn't planned to take it out till the third day. And it just looked like some random fungi, so I wrongfully assumed it was just contamination. But little did I know it was actually Streptomyces. And on the second day, I noticed that every single plate had these colonies, and I knew I had messed up immensely. To start the gram stains, I first needed to fix the bacteria to a microscope slide. Two popular ways of doing this are heat fixation and methanol fixation, which one requires methanol. In the past, I got a bottle of heat antifreeze from the gas station and put that in my freezer, and used that whenever necessary. But I found out the hard way that the bottle they use for it leaks, even when upright, so I haven't bought any since, and for that reason, I chose the safer alternative, heat fixation. I used my inoculation loop to smear an isolated colony and a drop of distilled water on my microscope slide, and waited for it to dry. Upon drying, I passed it through the torch 2 to 3 times, and it was now time for staining. I got out a bottle of crystal violet, grams iodine, which plays a part in tapping the crystal violet in the gram-positive bacteria, decolorizer, which is basically an alcohol and acetone mixture, and counterstain to stain everything unstained by the crystal violet. Now my crystal violet, it's in a media bottle because when I received it, it was leaking. To start the stain, I took my micropipette, set it to 1 milliliter, and with a non-sterile 1 milliliter tip, I piped out 1 milliliter of crystal violet and added it to the slide, while holding the slide level just above a pool of water in the crystallization dish. I then ejected the purple tip into my trash and then set a 1-minute timer on my watch. After 1 minute, I took a jug of distilled water and rinsed the slide. Then I put on a few drops of Graham's iodine, setting another 1-minute timer. Following that, with another rinse, and then very quickly, I had the decolorizer and immediately rinse it again. And then finally, I added a few drops of counterstain, and after 1 more minute and another rinse, I left the slide to dry. A few minutes later, I got out my microscope and turned it on and flipped to the 10x objective. I then added a drop of immersion oil directly to the slide and secured it to the microscope and focused on it with the objective. I was very pleased to find what appeared to be pseudomycelium with circular things that were probably spores. Now this is where the project began to fall apart. Notice how it's light pink? That means it's gram-negative, and Streptomyces is gram-positive, so it can't be Streptomyces. So I must have performed the stain incorrectly, right? I repeated the Gram stain, but now did the Graham's iodine and crystal violet stain for twice as long, and decolorized for half as long, and the result was still inconclusive. Some spots were appearing gram-positive, and some gram-negative. So what's going on? I assumed that my crystal violet had just gone bad, so I ordered a new one and I moved on to the malachite green stain. The best method to enlarge the spores is to use heat to expand them while staining. To do this, I chose to use a steaming water bath. In my case, it's just a crystallizing dish with water, with a rack from my incubator above a hot plate. So I set up a crystallizing dish of water above my hot plate with the heat fixated slide and quickly ran into an issue. I was failing to get the stain to go above 50 C, so I desperately moved the dish to the stove. But right when I started getting 60 to 70 C, the dish shattered from the heat. I got it from a garage sale before I knew the types of Pyrex, and I was like, ooh, Pyrex! So as I ordered a actual borosilicate one online, I just used a pot. Now at my stove, finally reaching 60 to 70 degrees Celsius, I started the 15-minute timer, and after it was finished, I dried off. I put it under the immersion lens to see no green, no endospores. There was still one way I had written down to test if they were spores, and that's spore stalks. If I filtered out just the spores, if anything grew at all, then we knew it was Streptomyces, because if there was no spores, then I would have filtered out nothing. I was supposed to put 5 milliliters of sterile distilled water over the bacterial lawn, mix it together with a sterile swab, and then filter it through what it referred to as autoclaved wad of cotton in a syringe. I really wish I knew where the heck I read this and thought it was a good idea. Good enough of one to give a dedicated spot in my lab notebook. And what the heck did I think when I was buying glass syringes? I autoclaved it with this cotton ball shoved in there. I probably should have stuffed it in the tip of the syringe, not in the barrel, but oh well. I had no idea what this was supposed to look like. Anyway, I couldn't suck out anything, and it got stuck in the tip, and I desperately tried to pipe it into the centrifuge tube, which clearly didn't filter out anything as it never passed through the cotton. But anyway, it's now in a centrifuge tube, which I was then supposed to centrifuge for 10 minutes at 9,000 RPM and squeeze out all the spores into a pellet at the bottom so I could change out the liquid above them for a sterile 40% glycerol solution to freeze and store it properly. But why the heck would I need to do that? That clearly had no purpose for this project. Why did I choose this? Why did I add this to my notebook? Maybe I just really wanted a reason to mess with syringes, my centrifuge, and glycerol, because I never really get to do that often. Anyway, this is when I complained to my friend on Discord, Epi, only for him to make fun of me for using malachite green on Streptomyces because its spores are closer to fungal spores than bacteria. Apparently endospores are bacterial spores that grow inside the cell, and exospores, or what Streptomyces spores are called, they grow outside the cell, on the surface of it. Maybe that's what caused it to fail staining under an endospore stain. I couldn't read anything about exospore stains. They all refer to it as an endospore stain. Clearly they didn't know exospores existed either. I also read, while researching it, that apparently Streptomyces can decolorize malachite green. So I went ahead and poured another plate of Streptomyces agar, but this time added malachite green, just to see if it's able to decolorize it. So it's been incubating for around a week. Nothing grew, except contamination from the dye. That's it. Well, stain. So I probably added too much malachite green. That's probably what happened. Or it just was never going to grow in the malachite green to begin with. Anyway, I still hadn't lost hope yet. I still had to figure out why my gram stains weren't working. I tested it again on the next day on a fresh plate with new crystal violet and got the same results. So I began to think, maybe I just suck at heat fixation. Maybe I just can't resist overcooking the cells when I do it. So I decided, why not just switch back to methanol fixation? But instead of using heat antifreeze, which leaks while sitting upright, I ordered some methanol on Amazon and an alcohol detector, so I could know if it was leaking and not repeat the same mistakes I made in the past. After leaving the methanol in my freezer overnight, I then prepared another bacterial smear on a fresh plate and slide with my inoculation loop, and while wearing a full-face respirator with 3M cartridges that protect against methanol fumes, I opened the methanol and piped out 1 milliliters of methanol, piping it onto the slide. And I kept piping on more until I believed I could last there 15 minutes without evaporating. I then waited 15 minutes and let the slide air dry, then proceeded to do another gram stain. And this time, when I put the slide under the immersion lens, I saw perfect gram-positive circles! Yes! Finally, found out why I wasn't staining properly. I just suck at heat fixation, apparently, and methanol fixation was the way to go. I should have just done methanol fixation from the very beginning. And now that we know it's actually Streptomyces because it's gram-positive, all I'm left with are 20 or so plates of Streptomyces and a big stack of lessons learned. I made a post to Reddit asking for any ideas for my future projects, and the first one that was mentioned was the Streptomycin Extraction. Streptomycin is an antibiotic produced by Streptomyces griseus. It was originally the first antibiotic to be found to be effective against tuberculosis. But after resistance and toxicity issues I partially blame agriculture for, it is no longer used on the medical side. Antibiotic resistance would make it so I would need much more of the antibiotic to have the same effect on the bacteria, or it just wouldn't work at all. But resistance issues aside, I would first need to figure out how to culture the Streptomyces bacteria in large enough quantities to make enough of the antibiotic. I decided on liquid culture so I could more easily grow large amounts of the bacteria, and so I could have the antibiotic dissolved in solution. Someone also suggested a modification to the liquid media I was going to use to increase streptomycin production. Instead of using a small glucose percentage as the carbon source, I would use 10% sucrose. Apparently, Streptomyces can't use sucrose as quickly as other sugars, and the high sucrose concentration creates osmotic stress in the Streptomyces. Streptomyces genes interpret all this as a chance for other microorganisms to catch up. So to allow the Streptomyces to still be able to compete in an environment like this, they prioritize its resources toward the production of antibiotics, which is just what we want. The antibiotics inhibit the growth of the competing microorganisms, allowing the Streptomyces to keep up. Antibiotics are actually really good at this. As you can see on this contaminated Streptomyces plate, it outcompeted the fungi because the fungi was inhibited by the antifungals Streptomyces griseus also produces. I began preparing for the Streptomycin extraction by first weighing out the ingredients I would need for the liquid media I was going to use, which I will refer to as the fermentation broth. Because of the slower growth, I wanted to try starting its growth in a smaller vessel with only 50 mils of the fermentation broth, so I could make sure it actually grows properly, so I could then add that to 600 mils more of the broth for the final incubation. I started out by getting a 1 liter media bottle and filled it with 1,000 mils of distilled water. To that, I added 100 grams of sucrose as the carbon source we discussed, 10 grams of peptone as the primary source of nitrogen. I then added 5 grams of yeast extract to cover the rest of the essential nutrients for Streptomyces growth. I shook the bottle until everything dissolved, and while misreading my notebook and missing the line about magnesium sulfate, thinking it's the calcium carbonate amount, I wrongfully added 0.5 grams of calcium carbonate to keep the pH balanced. And after autoclaving, the media was now ready for use.
There's agar. It formed a giant agar plate. Wow. What do you know? This is why you only fill your agar bottles half full when making agar.
There was one problem, however. The Streptomyces is non-modal, which means it can't move. Inside a liquid, this would really limit its growth and oxygen supply, as it would be stuck to the bottom. Also, our calcium carbonate I used to maintain pH must remain suspended since it is insoluble in water. I read about a device called an orbital shaker, which provides stirring as well as aeration to keep the Streptomyces oxygenated and the calcium carbonate suspended at the same time. I had tried doing this with just an autoclaved air stone in a magnetic stir, but it failed catastrophically when the media bubbled out of control. I bought both an orbital shaker and an incubator big enough to hold both, so now I can finally inoculate my flask. I added 5 ml of sterile distilled water to a plate of Streptomyces and mixed the spores into it with a sterile applicator swab. I then tilted the plate and piped out 5 ml of culture liquid and into the flask. I then secured the flask to my orbital shaker and let it incubate for 2 days. After 2 days, I very carefully transferred the culture media to the bigger 2-liter flask and 600 ml of fermentation broth. And while that was incubating, Someone suggested to use a special flask called a baffle flask, and I agreed. I got this cool flask. It's called a baffle flask. It has these things on the bottom called baffles. They're supposed to increase turbulence, which increases aeration, which increases oxygenation, which increases the amount of streptomycin I get out of the Streptomyces bacteria. So I'm going to transfer it to this, and hopefully this will increase my yield. I'm excited to find out if it does, although I probably won't because I'm not testing that at all. I have no way to know. But the problem is, its neck at the top is smaller, so it's much harder to get one of these in here. I could just, go full redneck or typical and just, use some foil and just leave it like that. But I don't like this. I got these perfect. I got these. I could just, if I could just find a way to get this in here. Getting this in here is really hard without like contaminating it. Because look at how low my finger is. When I put this in here, now the part my finger touched is in the inside. Condensation will leak all the bacteria from my finger down into the culture. So, how do I do this? I could cut off a piece of foil. And then I could autoclave this like this. And then this separately. Okay, that's excessive. But there, if I autoclave this right, probably a bit more foil, but I'd fold the foil out of there like this, and I'd have a sterile foil touching the sides. Now I can get low on it without contaminating on it, and this should, in theory, allow me to fully get this in here without ever getting my finger on it, or any part that isn't sterile. Now it's in here, and it's completely sterile. I don't want to burn myself. Wait, I forgot to swirl it. I only have one attempt at this. Burning myself on this light. After being transferred, I allowed it to incubate for one more night, and it was now time for the streptomycin extraction. For the extraction, I was following a publicly available method that was originally designed for industrially large cultures. The first step required me to filter the culture, but I only had super fine 0.22 micron filters. While ignoring that fact, I set up the vacuum pump and ran it, but one problem arose. It was way too slow, horribly slow. Hoping my stronger pump would help, I attempted to switch to it. Luckily, it mostly stayed on my wall and wasn't too hard to clean up. After finding out my stronger pump wouldn't fit, I ordered some coffee filters and pre-filtered the culture, and tried again, but only managed to get 100 mils after letting it run overnight and going through over 8 0.22 micron filters. All that for this. 100 milliliters. On the verge of giving up and starting over, I continued anyway and moved on to the next step. I added 1 grams of activated charcoal. and stirred it for around 30 minutes to perform something called a charcoal absorption. This would allow the streptomycin to absorb into the pores of the activated charcoal. 30 minutes later, the next step was to filter off the liquid. But it got clogged immediately. Not wanting to spend weeks vacuum filtrating, it was clear it was over. My first attempt at the streptomycin extraction was a complete failure, but I learned a lot from doing it. I decided to dump the culture and start over. Several improvements were made for the second attempt. To make sure the extraction wouldn't fail this time, I got an actual vacuum filtration setup with a Buchner funnel and 20 micron filter paper discs, which would hopefully filter much faster than the 0.22 micron ones I was using. And in case it didn't, I also ordered charcoal pellets as a backup method of charcoal absorption, in case the activated charcoal powder clogged too much again. And I switched to an actual media mentioned in a paper for Streptomyces growth, with a high sucrose concentration. This media was called modified yim broth, which importantly contained no calcium carbonate, which I feared was the ultra-fine culprit clogging my filter in the first place. I also ordered some better disinfectant, as I was just using 70% ethanol and Santa cloth, which still left spores behind, so I used something called sporecidin, which leaves a film behind that prevents the spores from germinating. I also got a clamp for my vacuum filtration setup, which after some testing proved to be quite effective at stopping it from falling over when bumped. In case spills still managed to happen, to ensure they wouldn't run off the table, I got a large metal spill tray to cover my entire table to act as a secondary spill containment. I could now handle spills much more safely. Also, after reading the paper on the streptomycin extraction more thoroughly, I found out their yield was only around 100 milligrams per liter. In fear of my product being so small that I wouldn't even be able to filter it off, I upped my culture volume to 1.5 liters, instead of 600 mils, using a second smaller incubator. To allow me to do this, I had fixed the foaming problem that I had came across with the air stones earlier, when I learned about anti-foaming agents from a Discord user, which made it easier to culture the streptomyces in liquid in large volumes without an orbital shaker. To begin culturing again, I started by preparing a splitter for the air pump for my 4 flasks I was going to put in the smaller incubator, and made sure the 0.22 micron PTFE syringe filters fit on it. I then got a large 5-liter media bottle to mix up the media. I then, instead of 1.3 liters of water like I was supposed to, I added 1.5 liters of water to the bottle and weighed out 4.5 grams of yeast extract, 7.5 grams of peptone, 4.5 grams of malt extract, 15 grams of glucose, and then a whopping 255 grams of sucrose. Then mixed everything together. I then added 500 ml to the baffle flask once it all dissolved, and then to prepare for the airstone flask, I added 10 ml of propylene glycol to the remaining liter of media to act as an anti-foam agent so it doesn't bubble up like last time. Although this was actually 10 times the amount I was supposed to add, which luckily didn't affect the growth that much. I then mixed it up and transferred it to the flasks, and added the airstone assemblies, and prepared everything for the autoclave, which turned out to be a real pain, because every time I ran into issues with airstone assemblies pieces falling off and having to scoop it out and autoclave again. Ended up having to autoclave a total of 4 times, and because of the high flask volume, they lost a lot of their media during the autoclave, which I didn't care much about, to be honest. I just didn't want to autoclave anymore. After everything cooled, I inoculated the baffle flask first and then carefully added the autoclave foam stopper and secured it to the orbital shaker. And then I inoculated the 4 250 ml flasks and hooked them into their incubator and turned on the air pump.
Now for the moment of truth. Let's turn it on. Please. Please work. Oh no, no. Don't foam, please don't foam. Oh, is it working? No way. Okay, wait, I gotta lift up the foil so I can see. Yeah, look at all the stuff floating around. It's moving around, so it's causing enough circulation to get everything moving, which is what we want. After 3 days of incubation, it was time to attempt the extraction again. I began by attempting to filter it through a cheesecloth, which I found to be quite stupid. So I swapped it out for a coffee filter, and deciding that still felt stupid, I set up the vacuum filtration setup with a Buchner funnel and carefully added a filter paper disc and gave it a good seal after pumping some distilled water with it. I then dumped out the water and ran the culture through it.
After seeing how fast it was, I wish I never used the coffee filters to begin with. I then made a test setup where I ran 1 grams of charcoal mixed with 99 mils of distilled water through the filter, and after seeing how successful it was, I decided the charcoal pellets weren't necessary at all, and added 20 grams of charcoal to the 500 mils I had filtered off, and stirred it for 30 minutes with my magnetic stirrer. After time was up, I got another filter circle ready and sealed in the Buchner funnel, and removed my stir bar, swirled the beaker to suspend the charcoal stuck to the bottom, and ran 500 mils through the Buchner funnel and turned on the pump. This was not as fast, however, so after around 1 hour, I had a nice dry charcoal bed. But this was so slow, I decided it would be faster if I did the remaining 500 mils separately. So I then followed the method by washing the charcoal bed by filtering 200 mils or 40% of total filtrate volume and water through, and dumped the liquid. It was now time for what it called the first solution, which involved releasing the streptomycin from the pores of the activated charcoal by adding 2% phosphoric acid. Its low pH would release the streptomycin into solution, to be filtered off, and then we would discard the charcoal. So I wrongfully prepared 200 mils, which was supposed to be 75 mils, of 2% phosphoric acid, by adding a little over 4 mils of 85% phosphoric acid to 200 mils of distilled water, and then filtered that through the charcoal bed, which it said was just as effective as scraping the charcoal off and suspending it and then filtering it through. Now with 200 mils of our elate with our streptomycin dissolved in it, I did the entire thing again for the remaining 500 mils. The next step was to neutralize the solution to pH 6 with sodium hydroxide, which after painfully doing for a while and adding over 100 mils, I realized my sodium hydroxide was incredibly dilute, and I had to put the elate in a bottle in my fridge so I could order some sodium hydroxide to make a more concentrated solution. After it arrived, I decided to make a 50% concentrated solution, so I weighed out 20 grams of sodium hydroxide and added it to 20 mils of water, and quickly put the beaker of it in a bigger beaker and began adding ice to the water around it. Sodium hydroxide releases heat when mixed with water as an exothermic reaction, so I needed to keep it cold until it was fully dissolved. After it was fully dissolved, I added it to a dropper bottle and carefully added it while checking the pH, and stirring until it was at pH 6. The paper said after this it would need to be filtered, so I filtered it before proceeding to the next step. The next step was another charcoal absorption, which required 4% activated charcoal instead of 1%, so weighed out 20 grams of activated charcoal and did another charcoal absorption for 30 minutes. And then after filtering off a fresh, dry charcoal bed through the Buchner funnel, I ran 160 mils of distilled water through it, and then 160 mils of neutral methanol through it, as instructed in the method. I also painfully found out my hydrochloric acid is not concentrated enough. So I put the charcoal bed in my fridge and waited for a more concentrated bottle of hydrochloric acid to arrive. Once it arrived, I prepared a 60 ml mixture of 2% acidified methanol by adding 1.2 mils of hydrochloric acid to 58.8 mils of methanol. I then scraped the charcoal off the filter in the Buchner funnel into a beaker and broke it down with a stir rod. Then added the acidified methanol in a stir bar and let it suspend for 30 minutes like the method instructed. I then filtered it off and filtered it again through a 0.22 micron filter because it still looked like it had some charcoal inside it. I was now supposed to neutralize the acidified methanol to pH 6 or 7. So I got out my dropper bottle and carefully did so, and when I overshot it, I fixed it with some hydrochloric acid, which was kind of scary seeing smoke when it did to the beaker.
Perfect.
I could finally precipitate it as this had converted the streptomycin into streptomycin hydrochloride, which was soluble in water, so it was ready. but I foolishly followed the instructions to dry it under reduced pressure to 1/8 its original volume. I don't have a drying oven or rotary evaporator, so I just used a vacuum chamber filled with desiccant. But because of my impatience, I accidentally made it overboil and spill all over the lid of the container, losing around 25% of it. And I still didn't learn my lesson, and tried putting some parafilm on, hoping that would stop it from spilling out. But it just blasted right through that, taking me down to just 20 milliliters left. I then decided just to precipitate it as is, and not risk drying it anymore. The method said to use either acetone or ethanol, and due to how expensive my ethanol was, I decided to use acetone, since it was easier for me to get. After cooling it in the fridge, I poured it into a flask of the 20 mils, and everything immediately turned cloudy. All I needed to do now was filter it off.
Whoa, that's cool. Look at it. It turned. Look at it. It turned. What the? Look at that. Wow. Wow. That's cool. Wow. Wow. Look at that. Look at how much powder is forming. So much powder. Oh, I wish I did this. I put this off for so long. Yes! 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 That went terrible. No.
Oh yeah, it turns out acetone dissolves the PES membrane used for these filters. I tested some ethanol after the failure to see if that would have worked, and it did. I had to start over. I had no sucrose left and no methanol. I had spent so much of my money doing this that I had to survive off rice and ramen for a whole month, and had to split my rent into 2 payments, because I would have ended up going 4 days without any food. But that wasn't enough to stop me from trying again. So I sucked it up. My next paycheck, I bought some more sucrose and methanol, and separatory funnels, and tons of acetone. After everything arrived, I weighed out the media, inoculated the flasks, incubated them again, filtered the media, did the charcoal absorption, first dilution, second absorption, second elution, and finally, now I'm all cut up again, 2 weeks later. This time, however, I'm not reducing to 1/8 its original volume, and I'm not filtering it off, because those were just designed to save solvent and weren't actually necessary. So I bought 3 extra bottles of acetone, so I could have extra for the precipitation, so instead of filtering it off, I could use separatory funnels. I first had to neutralize the acid though, which I let a friend do if you're wondering why their hair is brown.
No! It's fine. I'm gonna filter it when we're done.
Let's use it. Let's just see what it is anyway.
Yeah, I'll filter it, don't worry. It's so cool how it's like changing color, bro.
Yeah, it's cool.
Interestingly, the nasty green liquid turned clear when we did this, and some nasty stuff precipitated out when it turned clear, which we then filtered off. It was now time for the cool part. We prepared 5 parts acetone in a flask and poured 250 mils of it into 50 mils of the filtrate.
Oh,
Yes!
there you go.
Look at that! Yeah! Woo!
Nice.
Streptomycin!
Yeah.
Yeah!
Let's fucking go.
Look at that.
We then set up a 1 liter separatory funnel and poured everything in. I then mixed it up and let it settle. This is such a big optical zoom, so I'm using a phone for this. I don't have a fancy macro lens.
Wow, phones are pretty good actually these days.
My friend, now no longer present, I ejected off the powdery bit and added more acetone. I then put that in a smaller separatory funnel, ejecting off any precipitate that formed. Now I'm left with around 9 mils of wet streptomycin precipitate. It was now time to dry the product, which I daringly decided to do under reduced pressure in a vacuum chamber, this time being much more careful. I put it in the vacuum pump and removed the air, allowing the acetone to more quickly evaporate, which was really cool to see. The desiccant was releasing a lot of steam because I microwaved it, condensating on the side of the tube while the acetone evaporated. This worked surprisingly well.
So yeah, there's definitely still liquid in there, but it's very reduced. This is working really quickly. I might actually finish this tonight.
It's so close to done.
Oh, it's so close, it's so close. It's so close.
Is it the conical part of the tube? Yes, yes, yes. Does that mean it's done? I can't tell. It looks done. Yes! It's done! Yes! Yeah, I've dried it. Woohoo! Alright, so camera battery is dead, but now it's time to weigh it out. It's all dried out. I don't know if you can see it, but I'm gonna scoop it out and scrape it out into one of these wee boats back there. Weigh it on the scale to see what my yield is. Yeah! That looks about right. I got more than the paper did. Yeah! Nah, mine's probably not as pure. I can't measure the purity though. I'm not willing to spend $1,000 to measure purity. I'm gonna test it. But yes! Yes! Time to make the stock solution. Also, I found out there was more at the bottom of the centrifuge tube when I was throwing it away, and I put that on the scale. So I actually have 0.306 grams, which is more than the people who wrote the industrial method had gotten. Over 3 times as much per mil. So something isn't right, I'm thinking. Ignoring that, it was now time to test the product by doing something called a disc diffusion assay, or Kirby-Bauer. I acquired 6mm paper discs, which I got by borrowing a hole puncher at my workplace. I then labeled them and put them in the autoclave, along with everything else I would need. While I was autoclaving, I weighed out what I thought I would need for the antibiotic stock solution, which I decided at the time it was good to start with 100 micrograms per liter concentration. So I weighed out 20 milligrams of streptomycin hydrochloride and dumped that into 200 mils of PBS buffer to act as an isotonic solution for the bacteria. Once dissolved, I vacuum filtrated it into a sterile bottle to filter out any microorganisms in the stock solution. I now needed to prepare the stock solution blanks for the discs. I decided upon doing 2 controls at 1 micrograms a mil, 0.5 micrograms a mil, and then 10 micrograms a mil, 50 micrograms a mil, and 100 micrograms a mil. I then vortexed them and impregnated the now sterile discs with the corresponding blank. I now needed to streak a lawn of susceptible bacteria to the antibiotic to place the discs on, which someone on the Reddit post suggested using Micrococcus luteus, as it was supposedly very susceptible to the antibiotic. I had bought some beforehand and streaked a lawn of it on some nutrient agar while the Streptomyces were still incubating. To make the disc diffusion assay, I took my plate of Micrococcus luteus and streaked a lawn of it on a plate of standard method or tryptone glucose extract agar, which was the agar I was using to grow it. I then flame sterilized some tweezers, and once cool, I carefully placed each disc onto the Micrococcus luteus lawn, and put it away to incubate at 30°C. The results a day later were very confusing. Instead of having zones of inhibition, I had zones of growth? I decided my stock solution wasn't concentrated enough, and decided to try again. I also suspected that the reason the Micrococcus luteus grew better around the discs is because it's a halophile, which means it loves salt. The PBS buffer I used for the stock solution contained some salts, while the agar didn't. This explains why it grew better in the more concentrated discs, ignoring the 0.5% one. To test this, I made a second disc diffusion assay with 10 times concentration on my buffer to see how well it grew, and it grew extremely thick, confirming my suspicions of it being halophytic activity.
To make a stronger stock solution, I dumped my existing solution and weighed out 50 grams of my streptomycin hydrochloride and dissolved it in 10 mils of distilled water, which I then vacuum filtrated and made blanks for the disc diffusion assay with. After doing carefully yet another disc diffusion assay, a day later the results were still inconclusive, despite the massive increase to my stock solution concentration. But I then noticed something. With each disc diffusion assay, I also created a smiley face with discs and streaked the stock solution in the shape of a mouth for the smile part. I noticed that this had inhibition on the second plate, which means I must have just been impregnating the discs wrong this whole time, which I found out I was after realizing I wasn't adding a specific amount of the stock solution to each disc. I was just piping it until they were wet. So I increased the stock solution concentration way more and did one more disc diffusion assay and smile, carefully adding the discs, and a day later finally got the answer I had been seeking. I had inhibition zones formed around the discs in the shape of a smiley face. Unfortunately, I had made the lawn too thick on the actual disc diffusion assay, so only the most concentrated one had any inhibition zones, and it was barely visible. You are technically supposed to make a blank where the bacteria measure at 0.5 optical densities, but I don't have the tools to do that, so I just streaked it directly from a colony on a plate. This smiley face was good enough for me. It tells me I actually successfully extracted the streptomycin hydrochloride. This concludes the project. This project was very expensive to do. If you enjoyed it, please share this video with your friends, as I'm going to make more videos. I want as many people to see them as possible, as I had been working on this video for over 3 months. If you want to stay tuned, I would recommend subscribing and liking the video to let me know you want more. Once I am sure what the next project will be out of the many projects I'm doing right now, I will let you know as a community post. So you must be subscribed if you don't want to miss it. Also, please let me know in the comments if you have any project ideas, as I'm always looking for more reasons to use the lab. Anyway, thanks for watching the video, and I hope I wasn't too awkward to listen to.